The notes for 1.2 are on evaluating and simplifying expressions. And so in example number 1, we're going to simplify each of these. Quick reminder about exponents. Remember that the exponent on a number means it's how many times you're multiplying that number by itself. So 5 to the third, if you were going to write it out in expanded form, that's the same as 5 times 5 times 5. And so when you multiply those together, the product, or the answer that you get, that's the answer to the question. And so continuing on for these next examples, we're just going to look at some differences with negatives. Negative 3 to the third means that you're doing negative 1, or just a negative, and then 3 to the third is 3 times 3 times 3. And so the product of these gives you 27. The negative out front, because it's not included in the parentheses, keeps the value of the expression negative. Negative 2 to the fourth, if you were going to expand it, means you're multiplying negative 2 times itself 4 times. Negative times a negative is positive, times another negative would give you a negative, times another negative would give you a positive. So this is going to turn into positive 16. Negative 4 to the third power, written out in expanded form, would be negative 4 times negative 4 times negative 4. Negative times negative is a positive, times another negative would give you back a negative. And so the value of that expression would be negative 64. These 4 examples just included evaluating a numerical expression that contained an exponent. And these next 4, we're going to be following the rules of PEMDAS. And if you need to review those, they're given up here at the top for you. So in example E, 8 squared is 64, 3 squared is 9. Notice how I did the exponents first, and now I'll finish by adding. In a numerical expression, your answer is always going to be a single value. It could be a fraction, it could be a whole number, but you're trying to whittle these down to just be one answer down here. Every time you do a step of work, it should get a little bit more simple, a little bit simpler. So it's going to end up looking sort of like an upside down triangle. Remember, when you do PEMDAS, you always want to try to find what you need to do first. So here I'm going to start my work inside the parentheses. 1 plus 7 squared times 5 minus 3 gives me 2. After my parentheses, then I'll do the exponents. 1 plus 49 times 2. You can keep or drop the dot right there. Either way is fine. And then be careful, I'm not going to add these together first, even though it's really tempting to, because PEMDAS says that you need to finish the multiplication and then complete the addition. And so that's how we arrive at the single answer for that one. Again, notice that upside down triangle. Here on G, I'm going to start inside the parentheses, and then I'm going to do the exponents part first. So 8 plus 25 minus 6. And then that'll all be divided by 3. So I'm going to continue my work in the parentheses. I do addition and subtraction together as I see them from left to right. So this will be 33 minus 6 divided by 3. 33 minus 6 will give me 27. I can drop the parentheses here if I want to, or it's also okay to keep them. And then 27 divided by 3. The correct answer for that one in simplified form would be 9. Sometimes you'll have fractions. And so whenever you have a fraction, you're going to simplify the top and simplify the bottom separately from each other. And then at the very end, you want to make sure to check and see if you can simplify anything more. So I'll do the work separately. In the top, there's no parentheses, so I'll start with the exponent. And then in the bottom, there are parentheses, so I'll do the work in the parentheses first. It's okay on these ones to kind of feel like you're doing 2 steps at once, because you're simplifying the top and the bottom separately from one another. 16 minus 5 gives me 11 on the top. 2 times 11 gives me 22 on the bottom. And then this is what I was saying. Make sure that you simplify this at the end. 11 over 22. I can divide both of these by 11. And so I'll get 1/2 as my simplified answer for this problem. When you evaluate an expression, you take the given value for whatever variable or variables are in the problem and you substitute it. So it says evaluate 4x minus 9 when x equals 3. I won't do this on all the problems, but this number you're going to plug in here for the value for x. And then you'll simplify from there. Your answer for these ones, as long as they give you all of the values of the variable, should again just be a single number or a single value. So you're plugging the number in, and then you're just following PEMDAS to simplify. Same thing on this one, there's 2 numbers to plug in. So it'll be 3 times 2, and then 8 times 6. 6 plus 48, because remember you multiply first, and then once you multiply you add together. On C, there's two places that you need to plug in the value for x. And then once it's plugged in to both places where you saw the variable, then you'll simplify from there. I could do this exponent first. These can get multiplied together at the same time if you'd like to do that in one step, or it can be broken down into two, and then you'll finish by adding them together. D has a couple more steps, that's why there's extra space to complete this problem. Just be careful when you plug it in. See how this Q's inside the parentheses? I'm going to need to simplify here and then do the exponent, and then once I'm done I'll add it to whatever this value works out to be outside. So again, you start by plugging in the 2 to everywhere that you see the letter Q. I always like to go back and look at it and make sure I put it in all the right places, and then you'll simplify from there. I can multiply this 14 together outside if I want to first, even though that technically doesn't follow PEMDAS because this is separate from all of this. So as long as I multiply it together but then don't touch it until it's time to combine it, that's okay. I'll do my work inside the parentheses first, and then I'll continue simplifying inside the parentheses. Now that the parentheses are finished on the inside, it's time to do the exponent. And then last but not least, I'll finish by adding these values together. And so the simplified form for this one would be 41. When an algebraic expression has like terms and you're not given a value for that variable, you can simplify by combining them together. Remember that like terms, it's defined for you over here, but it's when the variable matches and the exponent on the variable matches too. So in example number 2, let's see, I can combine my h's and then I can combine my constants together. When you simplify them, you combine them by adding or subtracting the coefficients out front. So let's see, for this one, 8 take away 10 would give me negative 2h, and then negative 3 take away 9 would give me minus 12. We do write these usually with in standard order, where the part with the variable goes first and then the part with the constant goes second, but they can be written flip-flopped as long as you're careful with your signs and you'll get the same correct answer. Let's see. This one has y's, it has constants, and it has y squareds. So just remember, the y squareds can go with the y squareds, the y's can go with the y's, and then the constants can go with the constants. I use this underlining pattern to show you which ones can go together, but it's not necessary. You can use circles, you can use colors, whatever works the best for you. So negative 9y squared plus 3y squared gives me negative 6y squared when I combine them together. And then positive 2y and positive 6y gives me positive 8y when I put those ones together. And then last but not least, 5 take away 1 gives me plus 4 when I put those together. Be careful here, you can't combine these any further. They have to have the same exponent and the same variable to be like terms. So we just leave them as such. When expressions contain parentheses, sometimes they can be simplified by performing the distributive property. So remember, with the distributive property, you have a number out front that's being multiplied to each of the terms that are on the inside. When you do the multiplication, just make sure you're careful with your signs. That'll come up later. And then at the end, you want to simplify if there's anything else you can combine together. 7 times x gives me 7x, and then 7 times negative 4 gives me negative 28. Remember, these two can't be combined together any further because they're not like terms, and then you're not plugging in anything for the x, so you're not solving on anything with these. As you continue through these, just be careful with your signs. So negative 3 times x will give me negative 3x, and then negative 3 times negative 2, for this one, I'll get positive 6 as my answer. These two problems have the same elements as these. There's just going to be some more simplifying that you need to do after you do the distributive property. So on both of these, you'll start by doing the distributive property. When you do the distributive property, it only goes to the part that's in the parentheses right after the number. So this 2 is only getting distributed here, this 3 is only getting distributed here, and then afterwards we'll combine like terms. So I'll perform the distributive property, and now I want to do the same thing that I did on the last problem. So these two can go together, and these two can go together. When you combine like terms, just be careful with your sign. So 2 plus 6 gives you 8x, and then 12 take away 15 gives you minus 3. And you can't simplify those together any further because, again, these two aren't like terms and they can't combine. D only has the one distributive property, so that'll give you 12x minus 24. And then once you do that distributive property, now you can combine like terms here. So 12x plus 7x will give you 19x, and then negative 24 take away 8 will give you negative 32. So the distributive property also helps you simplify expressions. You can go ahead and cross out example number 5 on your notes. We're not going to do that one today, but we'll finish today with example number 6. So this is a verbal expression where you start by writing, you want to find numbers that model what's going on in the problem, and then question B asks you to do an evaluate step. Let's read the example together. So a company offers each of its 80 employees, so 80 is the total number of employees that there are, a computer that costs $15.50 or an iPad that costs $900. The first part says write and simplify an expression for the cost of all the equipment when n employees choose iPads. So if n is the number of people that choose iPads, I'm just going to make a note up here that n is an unknown. So if n of the people in the company choose iPads, that would mean that 80 minus n would stand for the number of people who choose computers. And that'll be important because we'll need that information when we write the expression. The iPads cost $900, so 900 times n would be $900 per iPad times n is the number of people who choose iPads. This would represent the cost of the total amount spent on iPads if n people chose iPads. And then the computers are $1,550, and there are 80 minus n people choosing those, because the number of people who choose computers is dependent on the number of people who choose iPads. If more people choose iPads, that would mean that less people would choose computers. It says to write and simplify an expression for this, so we'll just do the distributive property here to simplify, and then we'll combine like terms. So we'll do the distributive property and multiply. This is 124,000 minus 1,550n. And then when I combine my like terms, I can combine them here and here. Those two can combine together. So it's going to be, let's see, you can write this either way. You can put the value with the n first, or you can put it second. In this particular example, it would be more common to see it written this way, which is opposite from what was stated earlier in terms of standard order, but either way it'll work. So this would be the answer for A, the simplified expression for when n employees choose iPads. In example B, you're given that if 65 employees chose iPads, they want us to figure out the total cost for everything. So that would be 65 employees by choosing the iPads that cost $900, and then that would mean, let's see, 80 minus 16. So that would be 15 employees choosing computers, which cost this much. We don't have to do the math that way though. We can just use our expression that we found in part A, and we can plug the number 65 in here for n. So 124,000 minus 650, and then this is where the 65 goes. So you're plugging this value in for your n right here, and then we'll simplify from there. When I do the multiplication here, I get that value, and then when I perform the subtraction, the answer to the question is their difference. So if 65 employees chose iPads, and if the remaining 15 employees chose computers, this company with 80 people would be spending that much in terms of purchasing technology for their employees.